Hello, class, and welcome to another week of the F.O.I's, Fundamentals of Instructing. Today's plan is we're going to cover the navigation systems and radar services. But because of this homework assignment, I'm going to omit the radar services and just cover the navigation systems, which will include the VORs. Okay, some of the references that I used was the Airplane Flying Handbook and the Instrument Flying Handbook. Here are the reference numbers to those. Also, the FAR-AIM, Federal Aviation Regulation Aeronautical Information Manual, okay, 2023. Make sure you have the updated version. And I know they also come in the digital format on your iPad, which you can download off the internet. Some things that I also use to help me and which will also help you as the learner or the student is to use other resources available online, such as SkyVector, ForeFlight, which I have here on the iPad, which is very handy. VFR sectional charts, go old school. And then last but not least, verify you have your airport facility directory. Okay, moving along. We have the objective. So our objective of this material that we're going to be covering today is pretty much for you as a learner to develop an understanding and the basic fundamentals how VORs work in the navigational world in accordance to the navigation systems and airspace systems, which will help you guide you in times of need in VFR conditions, but IFR as well. Types of nav aids. So, based off of the navigation systems and radar services, we have VORs and satellite-based navigation. We're not going to go into the satellite-based navigation. That's for another topic and another day. But just to keep it simple and short, we're just going to cover VORs. Okay. Now, based off nav aids, what is a VOR? So, a VOR, you ready for this? A VOR is a very high omnidirectional frequency range. Let me say it again. A very high frequency, VHF, omnidirectional range. Okay? Meaning, for omni, meaning everywhere expanding. Let's just use an example like the sun. It puts out rays, so 360 degrees, like a compass rose. Okay, and then they can also be categorized into three types of VORs. So the first one being a VOR, as we just defined the definition of a VOR, we have a VOR DME, DME standing for Distance Measuring Equipment, which can, with the equipment on board of your aircraft, can also get the distance away or measure the distance away from that nav aid on the ground, and then a VORTAC. You have a TAC, pretty much tactical VOR, mostly used for military aircraft. Okay, moving along. How does a VOR work? Well, okay, so we're going to start off with the basic stuff. So it has a transmitter within the VOR, and it transmits these signals, okay? And in an omnidirectional direction, 360 degrees, and it uses, just like I said, like a compass rose, 360 degrees. The arrow is always pointed towards the magnetic north. Okay, so when you're looking at a compass rose, and now we'll draw it here, it's always going to be pointed towards magnetic north. Never true north. There are a few instances where you're in the far north, located in the northern hemisphere, where they are pointed to true north instead of magnetic north, but that's for a later video. Okay, radials radiate from the station in all 360 degrees. So as I showed you, you have 360 degrees. So we have our 90, 180, 270. So 1 degree per in a circle, which equals 360 degrees. And then the strange thing that confuses so many people is it doesn't matter what heading or direction you are facing from to or from the nav aid, the VOR in this instance. It's based on position not heading or movement. So don't get confused. We'll go further into that. And it has two transmitter signals, one that rotates around the VR every 60 seconds or 1 minute, and another one that is a reference or variable signal that sends out to your aircraft. Now, here's another example of how it works, to be continued. Okay, so in your aircraft, you have a CDI, which stands for Course Deviation Indicator. And then you have your OBS, your Omni Bearing Selector. Okay, your CDI is supposed to, as you're turning your Course Selector, Omni Bearing Selector towards the heading that you want to fly or the radial that you are on. So, for example, if you want to fly the 090 radial, you would turn your OBS to the 090, and also with the flag indicating to a 2 because you're flying to it. If you're flying away from a VOR, then you would get a from flag with a from here signaled, and you'd be flying the actual radial. So remember, when you're flying away from a VOR, you're flying a radial. Just like I explained, with the sun, it throws out rays and a 360-degree radial indication. So here's a prime example that I want to show you how it looks like from within your aircraft, and then looking from the top down of the direction from where you are located from the VOR. So flying directly to a VOR, we know that you're on the 180-degree radial because remember, from the station, radials radiate outwards. And it doesn't matter which direction or which way you are facing the aircraft from the VOR, you are on the 180 radial. So the indication on your CDI, as you've changed your OBS to the heading selector, because you're actually flying a heading of 0 degrees to the north to get to the station, but you are actually on the 180 radial. So you have the 2 indication. Here's another example to simplify the different types of VORs and what they would look like on your aerial chart, or your Sky Vector, or whichever you use, iPad on your ForeFlight. So this is the symbol of what a standard or typical VOR looks like. VOR DME, like I said, DME standing for Distant Measuring Equipment, so it's encased in the box. And then you have your Vortec with the bold on each 3 corners there for military operations. Okay, so quick question and a test quiz. What type of nav do you see here? And take your time. Okay, if you chose Vortec, you are absolutely correct. As you see here, Vortec, there's no square around it, and it's not a simple triangle. It actually has the bolded 3 corners, so it's a Vortec. And you can also tell on some of the charts, it will explain to you what type of VOR is present. Okay, so moving along, here's another example of radial, which radial you are flying example. So here, aircraft is on the 070 degree radial bearing from the VOR.